Okay. Hello, everybody. I'm Jodok. Nice to meet you. I'd like to tell you a little bit about Crate, what we are doing here. And first of all, we're going to start with just a few slides about Crate. We try to keep this briefly. And later on, I'd also like to show you some live stuff we do on the command line. As I said before, feel free to use the questions tab below or the chat tab, so I will look at it and try to answer as soon as possible. So about Crate. Crate is or why we made Crate. That's probably the first thing, is like we really believe in distributed applications. So we see that everybody is storing data, that more and more data is being stored generally, and that there is no way to store this on a single machine. So you definitely need multiple machines to do so. We were using MySQL databases or other databases with master-slave setup, and all of this was rather complicated to handle. So this is rather challenging to do something like this. And it's also pretty hard to scale. So that's basically the main reason why we were doing Crate. So Crate is real-time data store. We want it as an operational data store where you really get fast responses and also queries. And it's in the middle between SQL and NoSQL. So generally we use SQL is often connected to using joins and using transactions and things like that. But we rather believe in a SQL that is used to query data, not necessarily all the stuff that is attached with ACID databases. And we want to have it really, really simple to use and to scale, and combine it with search as well. So commodity hardware is definitely the way to go for us, and make it easy and simple to operate. We found that it has to be really easy to form a cluster. We don't want to have different nodes like a master node or a routing node that is connecting different things or doing queries, because this is hard to scale and to maintain. So we really want something that everybody can to use. And of course, the big data, or so-called big data, it has a possibility to use that is being used for a huge amount of data. So of course, we are aware of all the other things out there. There's a lot of technology out there, and we were using these things, and we also we're thinking about what can we combine, what can we use. So we position ourselves somewhere between SQL, like MySQL, on the other hand side, like MongoDB, which is the NoSQL data store, and combine it with the power of Elasticsearch. So we see ourselves as a database that is able to store also semi-structured document, binary objects, and make them available via SQL interface. Of course, it's open source, so this is very important for us. We are using open source software all the time, and we think that this is the way to go in future as well. One thing to mention is that we use Apache license, which also allows commercial use of our open source product. So compared to MongoDB, we think that our search capabilities are much better. There's also the setup and the scaling should be easier, or is easier. And on the other hand side, we were in great love with Elasticsearch. We're big fans of Elasticsearch, and we have been using Elasticsearch for a long time. And we wanted to have a system that is more database oriented. So the dump restore possibility, or to restructure the data inside the cluster. But generally speaking, we think that Elasticsearch and also the way it is forming a cluster is really, really great. So that's also one of the reasons why in the core we use Elasticsearch as a library. I'll tell about this a little bit later. And on the other hand side, a lot of people ask, how do you compare to Hadoop? So we think Hadoop is a totally different story because it's more batch oriented. It's not really real time and interactive. So inserting data just continuously let data flow into the Hadoop cluster is pretty hard. So we don't really compare to Hadoop. So, but just to know where we position ourselves. So what does great data do for you, or what do we think great data is interesting for? So we want you to use great data as single source of truth. So like a database, not just an indexing engine or a search engine that is being used afterwards, but as operational data store for structured data and tables, for semi-structured data, and also for blobs. And you should be able to query this in near real-time sub-second response. So the cluster, if you want to build easily a cluster, as I said, if you are in the same network, it's forming a cluster automatically. No complex setup for things like that. So to give you some numbers, it's very easy to run crate on a single node. So for development, you probably want it just installed on your MacBook, and you are able to index a few thousand documents per second. If you build a cluster, you easily can index thousands of documents per second. So that's something in mind where we want to have something that is really easy to adapt to the size of data you're using. So regarding the limitations, or you ask what are the best cases for that, is we typically see data sets in the size of gigabytes to petabytes. We haven't handled petabyte on our own yet, but we know that people using Elasticsearch are storing petabytes, and our storage is very similar. So that's something that should easily work. Sharding is built in. I think we don't need really to mention this. It's also possible to run more complex queries with MapReduce style functionality. So if you use the user-defined functions, we're gonna store. It's possible to inject functionality there. So we don't have user-defined functions yet, but the architecture, or what we have in mind there, is that we can also run these queries there. So what we see, what a lot of people do, or what we have been doing in the past, is combining different technologies. So using Riak as key value store, Solar or Solar Cloud for searching, and Rados as binary object store. That's totally valid solution, but it requires 3 different products, 3 different technologies to scale and to operate. Or a lot of people use MongoDB, and then if they want to have faster search, they add Elasticsearch and GridFS on top of MongoDB to store blobs, or CouchDB, Elasticsearch, HDFS. So what I'm saying is you have a zoo of technologies you need to babysit. You need to keep them in sync, and it's pretty. The setup is pretty complex. So we really wanted to have this in one product that is really easy to use and elegantly to scale. So we've been in the space of big data for quite some time. Although the company was founded last year, we've been working there for several years. And I just don't want to go over the slide. You can also download it later. But the thing is, our motto is basically the better, faster, cheaper, where we want to be among the first that provide a software stack for developers where you do not really need to worry about your storage layer. So you can easily have one storage for binary objects, for structured data, and for semi-structured data. So just a little bit about the internals. We see here on the top a cluster of many nodes. It's very easy to add a node, so you just add it to the network, or if you don't have multicast support in your network, you can also specify the list of the hosts, and then they will form a cluster. So they're sending a frequent heartbeat to each other via multicast and can detect which nodes are online and which nodes are not online. If you look into one single node, that's what's drawn below in a little bit larger. It's there are several components we are using. First of all, it's possible that the nodes talk with each other via the transport protocol, which is a binary protocol or a HTTP protocol. Clients generally will launch a HTTP query, and then the parser is analyzing this SQL query. We are using the Facebook Presto parser. We added support for some more statements like writing data, and then this query is being analyzed and an execution plan is made. So this is our component. This is also our piece of code we added to the Facebook Presto parser. And below this, this data or this request is sent via the transport protocol from Elasticsearch to the different nodes where the data is being collected first, and then probably redistributed to do further queries, and then merged, and the result is being sent back. Parallel, we also have blob storage where you just store the binary objects. They use the same HTTP endpoint and the transport protocol to talk with each other, but they are not using Lucene and these things to store. It's rather like really a key value store for binary objects. So now let's just try and play around a little bit with Crate. So we're gonna use the easy trial. I'm stop the full screen mode. We go to our website, and on our website we have this trial area. I just copy this command. I probably should mention that we also have the installers for Red Hat based systems, Ubuntu systems, or Arch Linux. So if you use Crate in production, you want to use these packages because they store the configuration files in the right location. They have the log path set up. So if you want to use it in production, you want to use the packages. But for us, the trial is easy. So I'm launching this command. It's downloading an installer script from our website. It sees that I already downloaded Crate. This will typically take a few seconds to download the tarball, unpack it, and then start Crate. As we have seen, it's starting the web browser, and it's starting with the sample data for the tweets. So there are some things we can configure. Before we start with the sample data, I'll just show you a few things. Just for the trial, there is no need to edit the configuration files, but I think it's worth mentioning that in case you change it for production. So you see, I created here, I changed the cluster name to webinar because in our network, the developers are using Crate demo clusters as well. And my Crate cluster would join this cluster immediately. But I don't want this for this webinar, so I created my own cluster name. It will not join the nodes in our network. There are some more things to configure. I think that's not important for this webinar, but you should take a look at the config file and potentially change settings. If you're running Create in production, you also want to make sure that you take care of the memory settings. So you can specify the maximum amount of memory Create is using. By default, it's using 2 gigabytes of your RAM. And you probably want to set this higher on the production server. So we launched a web browser, and we can import some tweets for testing. We see right now there are no tables, and what this import tweets for testing does is creating a table, then connecting us to the Twitter stream and importing. I'd like to show you how the table layout looks like, what this is doing, this JavaScript, so you have a better understanding of it. So it's going to create the table tweets, and has a primary key, the ID of the tweet. It has a timestamp created at, and it has a text field that is being indexed with a full text index. So you can specify a full text index for this field, but also for the source of this tweet, where it's coming from, retweeted, and things like that. So we also see that this is a nested object. That's something that's different from a traditional database. So you can easily create one field user, and this has some subfields, and they also can be indexed using a full text and things like that. You also see that we specify the number of replicas. How often do we want to keep a copy here? That's in this case, it's just the maximum amount of replicas that is possible. So if I start this importing tweets here, first of all, I'm asked to connect to my Twitter account. Just connect to it, and then it's starting importing tweets. So I have now 400 tweets imported. I can leave it running in the background. So if I leave this tab, it's still running in the background, and I just use this query here to run the first query. So if I execute this query, I receive the text of 100 tweets, but I can also select all the fields here and receive the fields of all of them. So if we want to look at the schema of this table, of course we can browse the table, and we also see the schema created at the timestamp, and that the user field is nested. But of course we can also do this via the command line. So if I do select everything from information schema dot columns, where table under name equals tweets, single commands, tweets limit 100. And I execute this query. We see that this table tweets has some columns. They have ordinal position, and we also see the nested fields there. What we probably should mention, that everything the admin UI does is done via SQL. So you can also, if you want to see what's happening, if you look at the tables views or things like that, you can easily use the web inspector and see what the cluster is, what kind of queries it is sending if you do this. So that's often also pretty easy to see the result set that is being sent, or also how you want to specify the queries. We can also do different some more interesting things. For example, if we want to create the histogram about the tweets, we have a function that is the date trunk. And let's say we want to do this by minute, and the column with the date is created at SD, and count them from tweets, group by D, order by D, sending limit 100. So we're running 1 minute, so that's the reason why we have 1,000 tweets in the last minute. If we wait a little bit, the minute should flip over pretty soon. But we could also, let's say, if we want to group not by millisecond but by second, then we see how many tweets we had per second. So we see 3, 4, 5, 6. These are the seconds there. So that's pretty easy to create here a histogram. We could also do other things like aggregation. So one thing I probably should also mention, and why we think that aggregations are important. If you think also like we compare to Elasticsearch, is that you send a query to the cluster and then you receive the results. But if you want to do, for example, distinct counts, or if you want to aggregate by a column, then you need a second step, so that the shards first of all are collecting their data, and then in the second step they need to count the data over a different column. So let's try to find all the users and how many followers they have. So if we select the user ID, which is the ID as ID, the sum of the user, and we want to have the follower count. As followers from tweets, group by ID, order by followers, sending limit 100. Then user followers count. Then we see, okay, the user with this ID has that many followers. So what happened in the background, and we see that that's really fast. I mean, we don't have a lot of records in there, but generally speaking, this is also almost the same speed if you have a larger data set and if you have more nodes. So that's, for example, something you could not easily calculate with a search engine. But search engine, of course, we can also do full text search. So if we want to search any tweets that mention the word Android, for example, is like we select the score of the document, and tweets where match text. Let's say Android backup. That's a word we just found before to happen pretty often today, but probably we have to change to a different search. Order by score, sending limit 100. Okay, Android backup was not there. Let's just search for Android, hopefully. Okay, we need to search for another word. So we just select some tweets, tweets, limit 100, and we search for, oh no, here we had Android tablets. Text, let's search for nice calm day, or just nice. We also have a history in the console. So if you put the arrow up, you can also have the history. So I'm looking for nice calm, and we find some results for nice calm. So if you see, if the score is higher than 1, it's a exact match. And if the score is below, it's here we just see nice, but the calm is not being listed there. So one thing I also wanted to show you is our create shell. So if I just take the statement to my clipboard, we could in the directory you downloaded, there is also a command line named crash, which is the create shell. By default, it's connecting to your local host. You can also connect to other hosts, and you can specify the queries here as well. So that's okay. Load argument must be an integer. Let's do a different query. Seems like I have a problem here. Select means 10. Okay, it seems like I should have tested this before. I have a different crash. Yeah, so it seems like I had a problem with my crash before, and you can use it here as well. This is using the client libraries, the Python client library we have in the background. So if you want to connect to Crate and if you want to start playing around with Crate, we have different clients here. We have a Python client. Our Python client is the most advanced client we have right now. We have a Ruby driver, and Active Record is still in the works. It's pretty well shaped already. And we have a Java client. We have a JDBC driver, which has been released today. It's not yet on the stable repository, but we have a driver for Java as well. Other drivers are community supported and probably not fully there, like for Node.js, like for Erlang. That's something you can find on GitHub. So on GitHub, Crate is our main repository. We are happy if you give us a star there. And I'd like to say basically thank you. I just wanted to give you a quick overview over Crate. And I'm happy to answer your questions via email, or also if you have some questions here, just send them over or drop you an email. So I just wanted to open the last slide, which shows the thank you. So this is my email address. It's Jodok, Jodok @crate.io. And in case you want to phone me, that's also my phone number. Thank you very much, and see you soon.